Hello dear students, Assalamu alaikum. I hope you will be fine. My name is Engineer Mir Masood Shah. I am lecturer in Department of Technology, Sarad University of Science and Information Technology, Peshawar, and I am teaching you the subject Design of Hydraulic Structure. Today is your lecture number 28. In lecture number 28, we will study about canal falls, their necessity and different types of canal falls. So coming to the topic, what is canal fall? Irrigation canals are constructed with some permissible wet slope so that there is no silting or scouring in the canal bed. But it is always not possible to run the canal at the desired bed slope throughout the alignment due to the fluctuating nature of the country slope. Generally, the slope of the natural ground surface is not uniform throughout the alignment. Sometimes the ground surface may be steep and sometimes it may be irregular with abrupt change of grade. In such cases, a vertical drop is provided to step down the canal bed and then it is continued with permissible slope until another step down is necessary. This is done to avoid unnecessary huge earthwork in filling. Such vertical drops are known as canal falls or simply falls. Next is a necessity of canal falls. So, what are the necessity of canal falls? When the slope of the ground suddenly changes to a steeper slope, the permissible bed slope cannot be maintained, as you can see in the figure. When the slope of the ground suddenly changes to a steeper slope, the permissible bed cannot be sustained or maintained at this point. So it requires excessive earthwork in filling to maintain this slope, as you can see in the figure. So in such a case, falls are provided to avoid this excessive earthwork in filling. When the slope of the ground is more or less uniform and the slope is greater than the permissible bed slope of the canal, as you can see in the figure, in that case also canal falls are necessary. In cross drainage works, when the difference between bed level of the canal and that of drainage is small, or when the FSL full supply level of the canal is above the bed level of the drainage, then the canal fall is necessary to carry the canal water below the stream or drainage. As you can see in the figure, the full supply level of the canal is above the bed level of the drainage or stream. So in this case we provide a canal fall to move the canal water easily below the stream. Next is the types of the canal falls. The following are the different types of canal falls that may be adopted according to the site condition. The first type is the ogee fall. In this type of fall, an ogee curve, a combination of convex curve and concave curve, is provided for carrying the canal water from higher level to lower level. This fall is recommended when the natural ground surface suddenly changes to steeper slope along the alignment of the canal. The ogee fall consists of a concrete vertical wall and concrete bed. Also, over the concrete bed, the durable masonry is provided in the shape of ogee curve, as you can see in the figure. This is the rubble masonry, above which surface finished with cement mortar. The surface of this is finished with cement mortar. This is the concrete vertical wall, and at this point a stone pitching is provided on the upstream side, you can say, and on the downstream side stone pitching is provided. Also concrete bed is provided. The surface of the masonry is finished with rich mortar 1:3. This surface is finished with cement mortar of 1:3. The upstream and downstream side of the fall is protected by stone pitching with cement grouting, and the design configuration of the ogee fall depend on the site conditions. So this is known as an ogee fall. Next type is the rapid fall. The rapid fall is suitable when the slope of the natural ground surface is even and long. It consists of a long sloping glacis with longitudinal slope which varies from 1 in 10 to 1 in 20. In rapid fall, curtain walls are provided and in between rubble masonry is provided. These are known as the curtain walls, and rapid falls are suitable when the natural ground surface is even and long. The longitudinal slope varies from 1 in 20 to 1 in 20. Curtain walls are provided on the upstream and downstream side of the sloping glacis. The sloping bed is provided with rubble masonry. The upstream and downstream side of the fall is also protected by rubble masonry. The masonry surface is finished with rich cement mortar. So on the upstream and downstream side also rubble masonry or stone pitching is provided, and the top of this the top surface of this rapid fall is finished with rich cement mortar in 1:3. This is the end of today's lecture.